So we're in section 8.6. All right, so law of cosines, let's draw a picture here. We don't have to have a right triangle. Guys, let's stop talking, please. And remember, we labeled our triangles. The angles were in capital letters, and the sides across from them were in small letters. And the law of cosines works for any triangle. And we're going to call it triangle ABC. And our sides are small a, small b, and small c. We get three equations. A squared equals b squared plus c squared minus 2bc cosine a. B squared equals a squared plus c squared minus 2ac cosine b. And c squared equals a squared plus b squared minus 2ab cosine c. Now, there are three equations. It's really just one equation. It just depends on which side we're looking for. And so what is this a squared equals b squared plus c squared? If we left this part off, what does this look like? It looks like the Pythagorean theorem. Well, it turns out that if we had a 90-degree angle in the triangle, cosine of 90 degrees, if I plugged in 90 degrees here, cosine of 90 degrees is 0. And that whole thing would go away, and we would just end up with the Pythagorean theorem. So this is kind of an extension of the Pythagorean theorem. What I'm going to recommend is don't try to remember three different formulas. Just relabel the triangles so that you only have to use one formula. Always label the side that you're looking for as A, and always label the angle across from it A, and then you only have to use one formula. It's not really three formulas, it's just one formula with different letters plugged in the different places. So we can redraw our triangle, not redraw it, just label the vertices and sides with the letters that we want to use. So that way you don't have to remember a bunch of different stuff. The other thing to notice about the law of cosines is if the side A is on this side, the cosine of the angle A is on the other side of the equation. So here I have side A, here I have angle A. And then the other sides that are over here are all B's and C's. So I have A on this side, B's and C's on this side, and then cosine A. Same thing here. I have B here, I have cosine B over here, and then A's and C's for my sides on the other side of the equation. Same thing here. We use law of cosines for side angle side triangles and side triangles. Those are the two types of triangles that we're going to use a law of cosines for. Little different than when we use the law of sines. We use the law of sines for angle side angle and angle angle side mostly. So what I want to do is do a couple of problems. One, we'll use the law of cosines to find a side, and the other we'll use the law of cosines to find an angle. So just do a couple of examples of the kinds of problems that you might see. And the other thing to keep in mind when we use the law of cosines is if we have to find more than one thing, if we have to find more than one side, more than one angle, we usually finish the problem with the law of sines. So we use law of cosines once, and then use law of sines. because law of sines is easier to set up and easier to work with. All right, so we'll do a couple of examples. One solving for a side, one solving for an angle. All right, questions on our equations here. Now, as we do the examples, I'm going to write out a lot of steps because I want to point out where people usually make mistakes. I'll write out more steps than most people will do in the problem. I just want to do everything so everybody sees everything in as many steps as possible so you can see how everything works. All right, so here's our first example. I'm going to start with a triangle here, and we're going to call this triangle X, Y, Z. And we're going to say that Y equals 14 and Z equals 8. And we want to find side X. So what I'm going to recommend here, this is what I was talking about before, instead of X, Y, and Z, let's rename the triangle. Since we were trying to find side X, let's call that side A. So this would be angle A, and then we could call this angle B, and this side B, and this angle C, and this side C. Since we're used to working with A's, B's, and C's, let's just rename that triangle. That way we won't have to worry about which one is A, which one is B, which one is C. I just name it the way I want it to be named. So we're going to find side A. So we have a side triangle. We have one side and an angle in between them. So we're going to use law of cosines. And the law of cosines tells me that a squared equals b squared plus c squared minus 2bc cosine A. And I'm going to plug my numbers in. So I have a squared equals b squared, 14 squared plus 8 squared minus 2 times 14 times 8 times cosine of A. So there are all my numbers plugged into my formula. Now I'm going to calculate this out. A squared equals 14 squared is 196 plus 8 squared is 64. 2 times 14 times 8 is 224, and I still have, and I forgot my cosine, this is 50 degrees. Forgot to plug that in. Cosine 50 degrees. Now I'm going to add these two together. A squared 196 plus 64, 260 minus 224 times the cosine of 50 degrees. Now here is the first place that a lot of students make mistakes. They see this 260 minus 244 cosine 50, and students say, okay, I'm going to subtract the 224 from 260. You can't subtract yet because the 224 is being multiplied by the cosine of 50. Order of operations says we have to multiply first. Yeah.
I can find the I know the cosine. I know like A is
50 degrees.
Okay.
Angle A is 50 degrees. So they gave us that in the problem. So the angle is, we name the angle by the capital letter. So this is angle A, and angle A is 50 degrees. So don't make the mistake of doing the subtraction here. Multiplication has to come first. So I'm going to plug cosine of 50 into my calculator and turn that into a decimal. So I get a squared equals 260 minus 224 cosine of 50, when I plug that in my calculator, I get 0.6428. And notice I'm keeping 4 decimal places. Now I'm going to multiply these two together. So a squared is 260 minus 143.984. So I multiply those two together. Now I can subtract. I've done the multiplication, now I can subtract. So a squared equals 260 minus 143.984 is 116.016. So here's the second place that a lot of students make mistakes, is they say, oh, I'm done. A is 116.016. But the law of cosines tells us a squared. So what do I need to do to find a here? Square root. A is the square root of 116.016. Plug that in my calculator and calculate that out, and I get a equals about 10.8, rounded to the 10. Now, like I said, I did a lot of steps here. You don't necessarily have to do every single step that I did here. I just wanted to show step by step how I'm plugging in the numbers, how I'm calculating, and the common places where people make mistakes. So I sort of wanted to make the steps as clear and as explicit as I could here. So I'm just plugging my numbers into my formula and calculating. Now this problem only asked us to find side x. If it asked us to find other angles in the triangle, I could finish the problem using law of sines now, because now I have this angle and a side across from it. And for example, I could do this side and I could solve for angle C, just like we did on our opener. Exactly the same kind of problem we just did on the opener. So I finished with the law of sines because law of sines is a little easier to set up than law of cosines. And we'll finish, on the next problem, we'll go and finish the problem with law of sines. All right, questions on that example? All right, let's look at law of cosines to find an angle. So here's my triangle for this problem. And I'm going to call this triangle P, Q, and R. R equals 3, P equals 2.5, and Q equals 1.25. All right, so we have a side triangle, and what we want to do is find all angles. So we want to find all the angles in the triangle. We have a side triangle. That tells us we use law of cosines. And usually when we use law of cosines to find an angle, we want to find the largest angle first. And I'm not going to go into details about why that is. When you go into pre-calculus, they'll talk about it a little more in pre-calculus. But we want to find the largest angle first. So I'm going to find angle R. How did I know that angle R is going to be the largest angle? This side is the largest side, and it's across from the largest angle. And let's do what we did in our last problem. Let's rename our triangle. Let's call this A, and this side A. And let's call this B, and this side B, and this C, and this side C. So we have A's, B's, and C's like we're used to seeing. And the law of cosines tells us that a squared equals b squared plus c squared minus 2bc cosine A. And I picked that particular one because we're looking for angle A. So I wanted the one that has angle A in it. So that's why I picked that particular one. Now we're going to plug our numbers in here. So I have 3 squared equals 2.5 squared plus 1.25 squared minus 2 times 2.5 times 1.25 times the cosine of A. I don't know what cosine of A is, so I'm going to be solving this equation for cosine A. This is like my x in my equation. I'm solving for cosine A. So let's calculate out these numbers. 3 squared is 9. 2.5 squared is 6.25 plus 1.5625 is this squared. Minus 2 times 2.25 times 1.25 is 6.25. Cosine A. I'm going to add these two together. So this comes to, when I add these two numbers together, I get 7.8125. On which part? Which part? Okay. All right. So I'm solving for cosine A. What do I need to do in this equation to solve for cosine A? I want to get cosine A by itself. What am I going to have to do? I could add 6.25, but this is with the cosine of A. Well, if I divide it by cosine of A, then I have to divide this by cosine of A also. So I want to get this part by itself. How can I get this away from the side of the equation? Subtract. There we go. So I'm going to subtract 7.8125. So when I subtract here, I get 1.1875 equals, those go away, minus 6.25 cosine A. Now we can do what we were thinking about doing earlier. What do I want to do to get this negative 6.25 away from the cosine of A? What is it doing to cosine A? Adding, subtracting, multiplying, dividing? It's multiplying, so I divide. And I want to divide by negative 6.25. So those cancel. And I get, when I divide this out, I get negative 0.19 equals cosine A. So I have the cosine of the angle. I want the angle. What do I need to use to find the angle? Use an inverse. So I get that A is the inverse cosine of negative 0.19. Make sure you keep that negative in there. And finally, I get that A is about 101 degrees. So we said that this was angle A, so that's 101 degrees. So I use the law of cosines, I plug my numbers in, and I solve for the cosine of the angle. And then use the inverse. Yes. All right, did the problem ask us to find just one angle? It says find all the angles. So now is when we were going to finish with the law of sines. Now I have if I'm looking for an angle, I have an angle side triangle. So I'm going to finish with the law of sines. So I'm going to set up a proportion with this angle and this side. We found that angle. And let's do, I'm just going to pick I'm going to pick that side, that angle, and that side. So this problem now looks just like our opener. I'm going to say that sine of C right here over 1.25 equals the sine of 101 over 3. So this is just like our opener now. Multiply both sides by 1.25. So I get sine C equals 1.25 times the sine of 101 divided by 3. And then I use an inverse sign. So sine C, when I plug this in my calculator, I get a decimal. Sine C is 0.4090. To find the angle, I use the inverse sign. So C is the inverse sine of 0.4090. Plug that in my calculator, and I get C is about 24 degrees. So this angle is 24 degrees. And finding the third angle should be easy now. How do I find the third angle? Add them up to 100, add these two and subtract from 180. So 101 plus 24 is 125. Subtract that from 180 and I get that this angle is 55 degrees. So found one angle with the law of cosines, finished the problem with the law of sines, and then I could add up the angles and subtract from 180. All right, questions on that example? So again, when I got to this place right here, you don't want to subtract the 6.25 from the 7.8125. These are still multiplying, so I can't subtract these two numbers. It's the multiplication has to come first. So that's why we subtracted this 0.78125 from both sides. All right, our homework.